Hello, this is Jeff Scott of Blackhawk Technical College. I have been doing several lectures based on the book that we're using for the 152-143 Intro to Java Programming class for the spring 2016 semester at Blackhawk. The book is starting out Java from Control Structures through Objects, 6th edition by Tony Gaddis. And during the first semester, we're going to go over, ideally, the first 10 or 11 chapters of the book. We may only get through the first 9, and that's okay. I've done lectures so far on the first 9 chapters, and I'm now going to begin my lecture on Chapter 10, which is on inheritance. So, our objectives are to discuss what inheritance is, how to call a superclass constructor, how to override superclass methods. We've talked overloading before, now we're going to talk overriding. Protected members, chains of inheritance, talk about the object class, which is kind of what everything in Java inherits from, the concept of polymorphism, which stands for many forms, abstract classes and abstract methods, interfaces, and we're going to talk about the difference between an interface and an implementation, anonymous classes, functional interfaces, and lambda expressions. So, what is inheritance? Generalization versus specification. And what they say in here is really in life, when we look at different things, basically everything is a specialized version of something else. They give an example in here and they talk about you've got insects, and a grasshopper is an insect, a bumblebee is an insect, etc. And they all have certain characteristics that they share, but they also have their own individual characteristics. I mean, bumblebees can sting where grasshoppers cannot, for example. So here's how you start to draw an inheritance relationship. And the arrow that goes up here means that the classes down below, bumblebee and grasshopper, inherit from insects. Another way of looking at it is bumblebee and grasshopper are children of the parent insect. So as mentioned here, in insect you can write all the attributes and all the methods that every insect would have, whatever it happens to be. Then in the bumblebee and the grasshopper, you can put just those attributes and just those methods specific to either a bumblebee or to a grasshopper in this case. When you work with inheritance, it's called an is-a relationship. Let me give you another example that's not in here. Let's say that I go to a bank and I open up an account. Well, that's not going to be enough. I can't go into a bank and say I want to open up an account. What I'll be asked there is, what kind of account do you want to open? Do you want to open up a savings account? Or do you want to open up a checking account? So let's say I want to open up a checking account. And they say, fine. Do you want to open up an interest-bearing checking account or a non-interest-bearing checking account? And I might say, well, what's the difference? And the person from the bank might say, well, for an interest-bearing checking account, you have to have a minimum balance of $500, let's say. And for a non-interest-bearing checking account, you only need a minimum balance of $10. So what you see is we came in there and first started to talk about a bank account. Then we had, under bank account, we have children like savings account, checking account, maybe an IRA account or some other account. But we went from bank account to checking account, and under checking account we had both non-interest bearing checking account and an interest bearing checking account. So as you can see, an interest bearing checking account is a checking account. A checking account is a bank account. So when they talk about the is-a or the is-an here, what you're saying is we're using inheritance. The reason that you use inheritance is you want to be able to extend the capabilities of the parent class. The parent class is also known as the superclass. The child class is also known as the subclass. And as mentioned here, the superclass typically is very general in nature. You're not going to actually create an object of that class. You're going to get more and more specialized before you start creating objects of the class. So the subclass is based on, or in Java terms, it's extended from the superclass. Superclasses are also called base classes. They're called parent classes. All right. Subclasses are called derived classes. They're also called child classes. The subclass inherits all the fields and all the methods from the superclass. And the idea is when you do that, you can then extend that to add more things that you need. Now, if we look at the example here, it says final exam extends graded activity. So what we're saying is a final exam is a type of graded activity. However, it's a specialized type of graded activity. So a final exam might have something, all graded activities might have something in common. You know, a number of points possible, a number of points earned, a grading scale or whatever. But a final exam might have something that's special, that's just by itself. So it's a type of graded activity, but it's a specialized type of graded activity. And as we look in here, you know, I see occasionally where the author makes mistakes in his own book, so I'd like to fix those if I can. Whoops, I wish I wouldn't have done that, but that's not too bad. All right, so what do we have in here? We've got final exam, which is a type of graded activity. What this means is, by default, all this stuff that's here is available down here. All right, but a couple things. First of all, you'll notice the plus sign here, here, and here. That means these are all public methods, as these are. But notice that the variable score is private, which means that score is only known directly inside of graded activity. So if I want to be able to jack with, for lack of better words, the score, and if I want to be able to jack with the score in here, I have to use these methods. All right, so all the stuff you see down here, num questions, points each, num missed, all right, the final exam, constructor, get points each, get num missed, these things are specific to a final exam. But final exam, since it's a child of graded activity, also has set score, and get grade, which gives it access to the score. Members of the superclass that are marked private are not directly inherited by the subclass. They exist in memory, but they may only be accessed from those public methods of the superclass. Anything in the superclass that's marked public is directly inherited and can directly be used by the subclass. As mentioned here, when an instance of the subclass is created, non-private methods are available through the subclass object. And we're going to learn about a new thing in here, because we've talked about public, we've talked about private, and pretty soon we're going to look at something that's known as the word protected. We'll get to that in just a bit. So we've got final exam equals new final exam. Then notice we call exam.setScore. Well, why am I showing you that? Because there's the exam, but setScore, they're calling it, even though it's part of graded activity, we can call it from final exam because it's public. Same with getScore. Non-private methods and fields of the superclass are available in the subclass. Okay. Now, notice here, constructors are not inherited. So if final exam is a child of graded activity, all right, and final exam has a constructor, it does not automatically call the graded activity constructor. Now, you may think, well, wait a minute, I'm reading this, it doesn't sound like you're exactly right. What you end up doing at the beginning of the child class is you'll say something like super, and that will automatically refer to something in the parent class or something up the class hierarchy. So the superclass constructor, as it says there, can be explicitly called from the subclass using the super keyword. We're going to look at examples of that, not right now, but we will look at examples of that when we go over the stuff that's in the book, okay? And I may or may not have mentioned this before, but when I go over the book, these are dry enough presentations as they are. But if I start going over the book, there's going to be so much duplication. So what we'll do is we will go over the stuff that's in the book. But then for virtually every chapter that's in here, what we'll do is we're going to write a simple payroll program in Chapter 1. And we're going to add to it in Chapter 2. And then we're going to add to it in Chapter 3, where we'll put an if statement in there. Then we'll add to it in Chapter 4, where we'll add a loop to it. And then we'll add to it in Chapter 5, where we'll break it up into more than one method. Then we'll add to it in Chapter 6, etc. So you'll see the same example that will be extended and extended and extended as we go on. That's going to be the majority of the other lectures that I give here, because I don't want to just read out of a book to you. It's bad enough that I'm kind of reading off of a PowerPoint here. All right. If you do have a super call, it must be the first Java statement in the subclass. Okay? All right. Overriding. Okay? What that means is, if we look back, way back here, all right, we've got a set score, we've got to get score, we've got to get grade. If we wanted to, let's say for a final exam, we set the score differently. Let's just say we did. We could take this thing down here, set score, exactly like it looks, and we could put it down here. What that would mean would be we would figure out how to set the score differently for a final exam versus for a graded activity. So what we're doing is we're saying, I don't want to use the parents method. I want to use by one of the same name, and it's got the same parameters and the same type, but I want to use it in the child. If you do that, that's what's referred to as overriding the superclasses methods. And that's method overriding. As it says, it's when the subclass has a method with the same signature as the parent class. So again, if we look down here, there's set score and there's set score. This set score is going to be a specialized set score that is just for a curved activity as opposed to a graded activity, because you do stuff when you're curving differently when you're setting the score. All right, but notice the set score, it's got a plus, so it's public. Set score, S:; void. All right, set score, S:; void. So everything that's in here and in here is exactly the same. But what we're doing in the child is we're refining the method that was originally written for the parent. A little bit of review here, as the author says. A method signature consists of the method's name and the parameters. So it's both the name and what's inside of the parentheses, not so much the return type like this. So the name must be the same. Basically, when you are overriding, everything that's here must be exactly the same here. All right. So a subclass method that overrides the superclass method must have the same signature. Typically, as it says here, you use the @override annotation just before the subclass method declaration. As it says, if what that does is if you screw it up and you don't make sure that this is written exactly like this one is here, the compiler will then flag it if you do an incorrect type of override. It's also possible in here, you can override anything, okay? And what they're saying here is a subclass method can call the overridden superclass method. So what is this, what? What does this mean? If I call super.setScore, that means call the set score of the parent. So in this case, if I'm here and I call super.setScore, that says, oh, even though there's one here, call the parent. All right, that's what the super there means. It says there is a distinction between overloading a method, which we talked about earlier, and overriding. When you overload a method, it has the same name but a different signature. When you override, it has the same signature. Both overloading and overriding can take place using inheritance. Overriding can only take place in an inheritance method. All right, that's why we saw overloading before, but we don't see overriding until right now. What if you don't want to allow something to be overridden? As it says, you can use the final modifier to prevent overriding from taking place. Now, this is considered really bad programming practice. What I'm saying is I'm creating this method that's named message. It's public, and it doesn't return anything, and it requires no parameters. But it's written so well that I don't want anyone ever to be able to override it. So I'm putting the word final there, which means that if some child class attempts to override it, they'll get an error. That's considered poor programming practice because you don't know when you create something, if farther down the line or at a later time, place and time or whatever, you might not want to override something. So although it's possible to do this, it's considered a poor practice to do it. All right. So far in this book, and we're going to talk about protected right now, but before we do, so I just want to mention to you that so far in this book, I don't know why, I know what that is. All right. But so far in this book, we've talked about this. We've talked about what we call access modifiers. I'm going to make this nice and big so we can all read it. All right, so we've talked about access modifiers. All right, and what we've looked at thus far is we've looked at public. And if something is public, that means it's available within the class and outside of the class. It's public. It's available everywhere, for lack of better words. We've also looked at, private. And private means it's available within the class only. Now we're going to talk about a new one. And that new one is called protected. And that's available within the class. And here, let's say available within the class. It is defined only. And I'm going to grab all of this. Except I don't want the only in there. It's available within the class. It's defined in and any child classes of that class. All right? What does that mean in English? I'll leave this up here for a second so you can look at it. In English, looking at the example we've been looking at in here, what that means is if we went back here and we said, for example, score, instead of making that private like we did, if we made it protected, that would mean we could change it here and we could change it here directly because that's a child of this. So again, as previously mentioned, when you start to do this, what you're talking about is you can, with protected, and let's go and look at what it says right here. With protected, it may be accessed by methods in a subclass and by methods in the same package as the class. So in other words, it's available class-wide, all right, and it's available to any children of that class. All right? So as it says, and it's not bad, a protected member is somewhere between private and public. All right? Using protected makes some classes easier, but it's considered a poorer way of doing it because now all child classes of the parent have unrestricted access to that member. It's better if you make all fields private and then provide public methods to access those particular fields. If you don't say public, and if you don't say private, and if you don't say protected, then it's given what's called package access, which means that everything that's defined in that package has access to it. And if you say, I don't know what that means, you'll understand it better when we start writing some code. So here's a chart that's taken directly from the book. And you'll notice that when you're talking about stuff that's within the same package, yes, 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 no, no. All right? No modifier, that's package access, no, no. Public, yes, yes. Protected, yes, but not outside. Private, no, no. And we'll talk about these in much more depth and breadth of coverage as we go on. All right, here's an example of what's called a chain of inheritance. So in other words, pass-fail exam is a child of pass-fail activity, which is a child of graded activity, which is a child of object. It's like, okay, fine, where the heck did that object come from? Object is at the top of the hierarchy in Java. If I create a program, all right, and I will be creating this later on in class, but I will be creating something that looks more like this. So I'll be creating something that looks like this. Public class payroll. All right, and we'll have a bunch of stuff in here. So there'll be a bunch of stuff. I'm just going to put ... to show there's some stuff in there. I don't really care. We'll be creating a bunch of stuff. But I could have, if I wanted to, also have typed in public class payroll extends object. Because every class that you declare in Java that doesn't extend anything automatically then extends object. So that's kind of the root class, so to speak. All right, it's the thing at the top. So classes are often stuck into a class hierarchy in different ways. All right? And depending on the complexity of the place that you work at, this right here is called a level 2 hierarchy. That's level 0, level 1, and level 2. Years ago, I took a class at the University of Wisconsin-Milwaukee Extension in downtown Milwaukee, and the teacher who taught the class was an engineer. He was from India. Very intelligent, very nice guy, very knowledgeable guy. And I remember because he had the same first name as his last name. It was Vieravan. And he worked for Johnson Controls in Milwaukee. And Johnson Controls, they write a lot of code for thermostats and the like. And he said that they went through and set up a class hierarchy for all of their code that they had. It took them 2 years at Johnson Controls. And this is a level 2 hierarchy. Imagine, he said theirs was about a level 500 hierarchy. So imagine the complexity. But when you start thinking about the complexity that goes into building something like a thermostatic system, okay, maybe it's not that hard to imagine then. I don't know. So again, all Java classes are direct or indirect descendants of object. Since object is in the java.lang package, you never need to write that down because it's just automatic. So in other words, as I showed you, this right here, all right, would have been totally fine to have written it like this. It literally is the same thing. As it says, because every class is directly or indirectly derived from object, every class inherits anything that's defined in object itself. What's defined in object? ToString and equals. In fact, even more than that. I've shown you this before. I'm going to show it to you again. I'm going to right now bring up a browser and I'm just bringing up Chrome here, and I'm going to type in java.sun.com. And it pushes me off to Oracle's Java page. I'm going to go down to Java APIs. I'm going to choose the newest, Java SE8. And over here, I'm going to peruse my way down until I find object. It should be in here. I've never done this before, but I don't know why it wouldn't. Object. There it is. There's actually two of them, so I'm not sure which one it is. Public class object. So there's a bunch of stuff in here. Okay, see also equals, clone, toString, notify, notify all, wait, another wait, finalize. So you can see all that stuff that's defined in that API is automatically inherited by any class that we create. So as mentioned right here, in the object class, the toString returns a string containing the object's class name and a hash of its memory address. If you want more than that, then you've got to override. And now you know what override means. The equals method accepts the address of an object and returns true if it's the same as the one you're checking it with. All right? So let's talk a little bit about polymorphism. Polymorphism means many forms. Okay? Now, I'm going to give you an example. Maybe not a good one, but it's the one I've used in the past, so I'm going to give you this one anyway. So, move this down a little bit. Imagine that I create a class and I call that class animal. Okay? And among other things, I decide for an animal, I'm going to give it a speak method. Okay? So then I'm going to define a method in animal that's called speak. Now, I start to create different kinds of animals. Dog, bird, cat, human, pig, cow. All right? And so what I'm doing, one more, duck. It looks pretty even now. What happens is if underneath class animal I create a speak method, all right, then I can go and I can override that speak method in each one of these. So each one of these down here can have their own speak method. So I have a speak for dog, I have a speak for bird, I'd have a speak for cat, I'd have a speak for human, I'd have a speak for pig, I'd have a speak for cow, and I'd have a speak for duck. Well, why would I want to do that? Well, it should make sense why I'd want to do that. Because if I call speak for a dog, it's going to say bark or woof or something. For a bird, it'll say tweet. For a cat, it'll say meow. For a human, it might say hello. For a pig, it'll say oink. For a cow, it'll say moo. For a duck, it'll say quack. So in other words, if I call the speak method, the system will look and say, oh, if that speak method is being called for this type of object, a dog object, I know to say woof. All right, so why am I telling you that? Because that's pretty much what polymorphism is all about. So they say here, a reference variable can reference objects of classes that are derived from it. So I can say graded activity is a type of exam. All right, so exam rather is a type of graded activity. So now it says we can use the exam variable to reference a graded activity object. All right, and what I just did was I might have made it even more confusing than it was. But it says that when something is polymorphic, it can take on many forms. That's literally what polymorphic stands for. So, looking at that example we were just looking at, what this says is the system will know what speak method to call based on the type of object speak is being called on. It knows for a human to say hello, but it wouldn't say hello for a cow. It would say moo. It wouldn't say moo for a dog. It would say woof. It wouldn't say woof for a duck. All right, so the system knows which copy or which implementation of the particular method to call based on the object that called it. And that is what polymorphism is. All right, that might not be the exact same definition that's given here, but it is what it is. Polymorphism is connected with dynamic binding. We talked about dynamic binding earlier. When you think dynamic binding, it means runtime binding. So the system can figure out at runtime, all right, when polymorphism is being used. That's exactly what they're talking about right there. All right. Earlier earlier I showed, or I mentioned, I don't think I showed it to you, but earlier I talked about something like this. Let's move this down a little bit here. And I said, I walk into the bank and I say, you know what? I want to open up a new bank account. And I'm asked, what kind of bank account do you want? Do you want a savings account? Let's keep it simple. Let's say that our bank, we have a savings account and we have a checking account. Okay? And we say, oh, no, I want to open up a checking account. All right, then we're asked next, is that an interest-bearing checking account? Or is it a non-interest-bearing checking account? Well, what I'm getting to here is I'm starting to draw a class hierarchy. This is level 0, this is level 1, and this is level 2. All right? And really, when you look at it in here, and I'm not maybe doing a great job of showing you this pictorially, but I can come up here, and if I wanted to, all right, I can draw something that looks like this. Again, it won't look beautiful or anything, but just so you get the idea. All right, so what you're seeing here, and again, these are my crude little graphics, all right, but I'm starting to show you how the hierarchy would be drawn. Like I said, I don't have any kind of program here that I'm using to do this, so this is about as crude as it gets, but I believe, or hopefully at least, you're getting the idea. So we've got a level 2 hierarchy here. At level 0 is bank account. At level 1 is both savings account and checking account. And at level 2 is interest-bearing checking account and non-interest-bearing checking account. So why am I showing you this right now? Well, if I walk into a bank and say I want to open up an account, they're going to ask me, what kind of an account do you want to open? If I walk into a pet store and buy something and I say to somebody, I just bought an animal, they're going to come back and say, what kind of animal did you buy? All right? So sometimes when you make a statement like animal, or you create a class like animal, or you create a class like bank account, and all of these should have been in uppercase. I'm sorry that I didn't do that. The speak can be in lowercase. But every one of these, and I'm just showing it because that's the way I should have written it, should be in uppercase. Oops. All right. So every one of those, like I said, the way that these are all written here, the parens really and truly aren't that important. They really aren't. But animal is way too generic. So I'm never going to create a class, I'm never going to create an object that's of type animal. Instead, I'm going to create an object of type dog, or of type bird, or of type cat, or human, or pig, or cow, or duck. In the same way, I'm never going to create an object of type bank account. Instead, I'll create one of type savings account, or interest-bearing checking, or non-interest-bearing checking. So why am I telling you this? Because bank account here, like animal up here, since those are classes that will never be instantiated, those are what are known as abstract classes. There is never any thought given to instantiate those. Rather, those classes are created so that subclasses or child classes can be derived from that class. So as it says, an abstract class serves as a superclass for other classes. It's a generic or abstract form, okay? So you say public and then the word abstract, then the word class, followed by the name of your class. An abstract method, not only can you create an abstract class, you can create an abstract method. If you create an abstract method, it has no body. But what it does is you put an abstract method in an abstract class. And what an abstract method in an abstract class says is if I have, for instance, I had speak in there, like we looked at before. Speak was in the abstract class that was called animal. And if I put speak in there and I make it an abstract method, so I do something similar to this, that means that any class that is a child of animal, and what did we look at before? We had cat, we had dog, we had bird, we had pig, we had cow, we had duck, and we had human. Those must all have a speak method in them. If we do not do that, we're going to get an error message. So we'll look at this example that's in the book that talks about students, but I'm just not going to do it right now. All right? And it says there that if you create an abstract method like this, you don't put any body in it, so it looks like this. Any class that contains an abstract method automatically should be set up to be abstract. But it is totally legitimate for you to have non-abstract methods inside of an abstract class. All right? But if you do it like this, and you put an abstract method in an abstract class, and if a child class fails to override that method, you'll get a compiler error. So as it says, you do it like this, you put in something like this in an abstract class to make sure that the subclass implements the method, and it can implement it in whatever way it wants to do it. All right? Now, just one more thing to mention here, okay? So I'm going to come in here, and again, I'm making all this stuff up as I go along, but I'm going to come in here and say this, and I'm going to say public class employee, and what I'm going to do is I'm going to say public class employee extends person. So and that should make sense because an employee is a person, okay? But what if I wanted to say not only does an employee extend a person, okay? Let's just say we also want to say that they extend something else. So I don't know. An employee is a person, and an employee is a human, as an example. So in other words, and maybe you might say human and person are the same thing, but let's just for sake of argument, I cannot do this in Java. I can't say public class employee extends person, comma, human, or human, comma, person. If I have an extends in here, I can only have one parent. That's the rules, because Java does not support this. If it supported this, it would support what's known as multiple inheritance. And Java is one of the languages that doesn't do that. Most languages don't. They only allow single inheritance like this. So I can say that it extends person or it extends human, but I can't do both. But what if I want to do both? All right? In other words, this is fine, but I want to be able to add some stuff in there for a human. Then what I can do is instead of creating another class that's called human, I can create what's called an interface. Notice an interface is similar to an abstract class in that it cannot be instantiated and all of its methods must be written elsewhere, so in other words, overridden. But an interface is like a contract. The difference is you can only extend or inherit one class, but you can have as many interfaces as you want, and they're going to show you that in here. So when you create an interface file in Java, this is what it looks like. Public interface followed by the name of your interface and then some code inside of there. You save it as a .java file, but there's no class in it at all. So you can do, and there's an example. Public class, final exam 3, extends graded activity, implements relatable. Again, the big thing here is I can implement as many interfaces as I want. So I could say relatable, hello, goodbye, mom, etc. So I have to write a relatable interface, a hello interface, a goodbye interface, and a mom interface. But if I did that, then it would be totally legit for me to implement. So Java, like most other programs, only allows single inheritance, but it allows multiple interfaces to be inherited. Now, sometimes we're going to read through this stuff, and you're going to say, you know what? It sort of made sense when you went over it, but not exactly. And then you went over it again. It sort of made a little bit more sense, but still not exactly. You're going to have to take the time to read the book and look at the examples. That's about all I can tell you. Interfaces can have not only methods, but they can have data. But any data that they have should be set up as constants. Okay. Again, I already showed you this where you can implement multiple interfaces, and that's what the author is showing here. This is how you show an interface in UML, or the Unified Modeling Language. You use the dash line right there, and notice the arrow is pointing to the side, not upwards, because it's not a parent. Java allows you to create reference variables of an interface type. This is getting pretty heavy. So we'll look at this example a little bit later. Okay? Again, I'm not going to go over this DVD example that's in there right now. Okay? All right. Just a couple more slides here. In fact, let's see. Just about finished. I wish that he would always do this, but all right. So just a couple more slides, like I said. Starting in Java 8, which is basically, I think, the version of Java that's being used right now, interfaces can include default methods. As they say, a default method is an interface that has a body to it. You can add new methods to an existing interface without causing errors in classes that have already implemented that interface. So interfaces are getting, for lack of better words, stronger. And the chapter ends with anonymous classes. What an anonymous class is it is a private class that you write inside of a public class. So as it says, an inner class, which is what an anonymous class is it's a class defined inside of another class. It doesn't have a name. That's why it's called an anonymous class. All right, it must, by default, by its very nature, either implement an interface or extend another class. This is something that may not make a lot of sense now, but that you will use a lot in the advanced class and in the Android class. So we'll look at it in more depth and breadth of coverage at that time. Finally, the last thing that's discussed in here, functional interfaces and lambda expressions. As it says, a functional interface is an interface that has one abstract method. We'll look at the examples that are in the book. Lambda expression, as it says, can be used to create an object that implements an interface and overrides its abstract method. In Java 8, these features work together to simplify code. What ends up happening when you have lambda expressions is, in some way at least, your Java ends up looking more kind of like jQuery. I'm going to leave it at that, and we'll talk about that in a later chapter. And that's it for Chapter 10.